Hello, good morning, dear students. Welcome to Interactive Virtual Class Nagaland once again. So, students, in our previous class, we have discussed about what is combustion. Students, so a combustion is a chemical process in which a substance reacts with oxygen to give off heat. All right, and we have also discussed about the essential components for combustion. We have discussed three essential components, that is air or oxygen. Then second is heat. Yes, the substance has to attain ignition temperature to start burning. To attain this ignition temperature, heat is required. And the third essential component is combustible substance called as fuel. Okay, fuel or combustible substance. So we will continue with the same chapter, that is combustion and flames, in today's class. So here we see different examples of combustion. We see burning of diya. Here firewood is burning of incense. Then we have this burning of crackers. So we have examples of different combustion here. So the question is, do you find any change in every combustion appearing here? Or are they the same? Okay. Are they different, or do you find any similarities or any difference in the combustion appearing here? Yes, students, we see here different types, right? There are different types of combustion. So we will discuss one by one. So here we see a gas stove. Now let us observe. We see a person bring a lighted matchstick, and turn on this switch, turn on this stove. What happens? We see that the gas starts to burn rapidly. Yes, students, the gas starts to burn rapidly. So this type of combustion is known as rapid combustion. Okay, this type of combustion is known as rapid combustion. So what is rapid combustion? Rapid combustion is instant combustion with the release of large amount of energy in the form of heat and light. So when we bring lighted matchstick near the gas, it starts to burn instantly, right? It also releases heat and light. So such type of combustion is known as rapid combustion. Here we see, another example. Bring lighted matchstick near a diya. So we have this rope. It burns instantly. Yes, so this is another example of rapid combustion. Alright, students, we have the first question for today. Please get your rough devices ready. The question is, combustion is a, option A, chemical process, option B, physical process, option C, both of these processes, option D, none of these processes. So we have four options. I'm giving you 15 seconds to respond to this question. Your time starts now. Combustion is a chemical process, physical process, both chemical and physical process. Option D, none of this process, that is not chemical process, not a physical process. Alright, students, your time is up, and yes, very good. The correct answer for this question is option A, that is chemical process. Combustion is a chemical process. Alright, students, let us see. Next type of combustion. Here we see that sodium pieces. Sodiums are metals which are stored in kerosene. We see that these sodium pieces are stored in kerosene. Now let's see what happens when we take them out and put into this plate, in open air. So take out some pieces of sodium and let's observe what happens. Now, if you have observed carefully, you see that we did not supply any heat to these sodium pieces, but it catches fire on their own. It started burning on their own. Yes, students, when it is stored in kerosene, it does not catch fire, but when it is put in open space, when it comes in contact with oxygen, it catches fire on its own. Yes, so this type of combustion is known as spontaneous combustion. Okay, this type of combustion is known as spontaneous combustion. So what is spontaneous combustion? Combustion which takes place spontaneously without any external heat supply. Okay, so we did not supply any heat to the sodium pieces. It catches fire on its own when it is exposed to air. So such type of combustion is known as spontaneous combustion. Another example we have is white phosphorus. Okay, the ignition temperature of white phosphorus is 30 degrees Celsius. So when it comes in contact with oxygen at room temperature, it will catch fire on its own, even without any external heat supply. So this is another example of spontaneous combustion. So here white phosphorus is stored in water. Okay, sodium is stored in kerosene, white phosphorus is stored in water. Alright students, we have another question. Please get your rough devices ready. The question is, the substance that catches fire spontaneously in the presence of air at room temperature is, okay, we have four options. Option A is white phosphorus, option B is rhombic sulfur, option C is calcium, and option D is iron. So which of the following option is the correct answer? Okay, which of these substance catches fire spontaneously in presence of air at room temperature? So for this question, I'm giving you 15 seconds. Your time starts now. The substance that catches fire spontaneously in presence of air at room temperature is which of the following? Yes, students. Alright students, your time is up, and yes, good. The correct answer for this question is option A, that is white phosphorus. Okay, the substance that catches fire spontaneously in presence of air at room temperature is white phosphorus. Alright students, let us see next. Okay, so here we see a boy. Okay, when he ignited these crackers, it exploded, right? There is sudden reaction and there is explosion. So this is another example. Okay, this is example of another type of combustion known as explosion. So what is explosion? Explosion is a quick combustion. Okay, explosion is a quick combustion with a sudden release of enormous amount of energy in the form of heat, light, and sound. Okay, I'm repeating this. Explosion is a quick combustion with sudden release of enormous amount of energy in the form of heat, light, and sound. Now, do you know, okay, why sound is produced during explosion? There is loud sound. Okay, loud sound is produced during explosion. So why so? Okay, yes, students, do you know? It is because there is rapid expansion of gases. Okay, there is rapid expansion of gases which produce loud sound during explosion. Alright students, we have another question. Please get your rough devices ready. The question is, one day Bhavna was singing during an off period which engaged all the students and created a lot of commotion in the class. The maths teacher angrily came and asked with rage, okay, who was singing? Why are you disturbing other classes? All were silent, but Bhavna came forward and admitted that she was the one and it wouldn't be repeated again. So what quality did Bhavna exhibit? Okay, we have four options. I'll give you 15 seconds to respond to this question. Your time starts now. So what quality did Bhavna exhibit in this situation? Honesty, fraternity, swachhata, resilience. So which quality did Bhavna exhibit? Yes, students, very good. The correct answer is option A, that is honesty. The quality that Bhavna exhibit in this situation is honesty. Alright students, let us proceed. Now, here we have a cup of water and we have thermometer. Thermometer is used to measure temperature. Okay, so let us see. Let us measure the temperature of this water in the cup. So we see that the readings on the thermometer is 25 degrees Celsius. Yes, students. Now, take the thermometer, okay, and put the thermometer in your mouth to measure the temperature of your body. So what do we observe here? We see that the temperature of our body is 35 degrees Celsius. So which temperature is more? This water or our body temperature? Yes, students, we see that the temperature of this water is 25 degrees Celsius and the temperature of our body is 35 degrees Celsius. So the question is, okay, our body temperature is higher than the surrounding. Why is it so? Our body temperature is higher than the temperature of the surrounding. So why is it so? Is there some combustion taking place inside our body, okay, that produce heat or that release heat? Yes, students, let us see. Yes, you were correct. Okay, you were right. In our body, there is combustion taking place. It is because here we see glucose is burned with oxygen to release heat and energy. And this process takes place inside our body. You have already learned in lower classes. Glucose burned with oxygen to release heat and energy. And that is why we observe that our body temperature is higher than the temperature of the surrounding. So what type of combustion is this? Okay, what type of combustion is taking place inside our body? Is it rapid? Is it spontaneous? Or is it explosion? Or is it other type of combustion? Let us see. Okay, so the type of combustion taking place inside our body is slow combustion. So what is slow combustion? The reaction which takes place slowly and gives less amount of heat and energy is called slow combustion. Okay, so slow combustion, glucose burned in the presence of oxygen to give off heat and energy, is a type of slow combustion. Okay, so the reaction which takes place slowly and gives less amount of heat and energy is called slow combustion. Other example of slow combustion includes rusting of iron. Okay, you must have seen the rusted iron. So rusting of iron, digestion, respiration, all these are examples of slow combustion. Alright students, we have another question. Please get your rough devices ready. The question is, the combustion which occurs on its own without any external supply of heat is called option A, explosion, option B, rapid combustion, option C, slow combustion, option D, spontaneous combustion. So we have four options. I'm giving you 30 seconds to respond to this question. Your time starts now. Okay. The combustion which occurs on its own without any external supply of heat is called which of the following? Explosion, rapid, slow, spontaneous. Yes, students. The combustion which occurs on its own without any external supply of heat is called explosion, rapid combustion, slow combustion, or spontaneous combustion. Alright students, yes, very good. The correct answer for this question is option D, that is spontaneous combustion. The combustion which occurs on its own without any external supply of heat is called spontaneous combustion. Alright students, so let us see here. We see here a man, okay, watching news on television when suddenly he expressed, okay, because he was shocked to see this, so he expressed saying, oh my goodness, okay, oh my God. Then his son entered the room and asked his father, Papa, what happened? Alright, then the father replied, see, there is a fire accident nearby town and the building is severely damaged. Okay, so here we see on television that the building is on fire and the building is being damaged badly. So here the boy asks his father, Papa, is fire so dangerous? Okay, then the father replied, yes, fire is very dangerous if it is not controlled. Okay, so know this. Okay, know this. We see here different types of combustion, and we use fire for different purposes. For cooking, to keep ourselves warm, to get the light, or in case of crackers, for enjoyment, right? So we use fire for different purposes. But if fire is left unattended, it may turn harmful. Okay, it may turn harmful. It may lead to damage of properties. It may also lead to loss of lives. So what we have to do is we should never leave the fire unattended, and it should not be left uncontrolled. Alright? Alright, students. So how do we control fire, or how to control fire? Now, if you remember the three essential components for combustion, yes, we have here the three essential components for combustion can be represented in the form of fire triangle. So we have fuel, heat, okay, we have fuel, heat and oxygen. These are the three essential components for combustion. Now, how do we control fire? These 3 points are essential for combustion to take place, or for fire to burn. So in order to control fire, we can remove either one of these essential components. So let's see. If we remove fuel, okay, there is oxygen and heat, but fire will not burn. Yes, students? The next, if we remove oxygen, then we have fuel and heat, but the fire stops burning because oxygen is not there. The next we have oxygen and fuel. Okay, we have oxygen and fuel, but heat is not there. Heat is absent here. So fire is not burning, as we can see here. So in order to control fire, okay, we can control fire either by removing one of these essential components, that is oxygen, fuel or heat. Okay, so how do we remove them? Let us see. Here we see that a house is on fire. Then we see people rushing to the side. Fire brigade arrived and they are pouring water on this house to stop the house from burning. Here we see forest is on fire. We see forest fires. Now when there is forest fire, you must have seen that they use helicopter, okay, to pour water or to drop water from above to stop the forest fire. Yes, students? So here we see that we use water in both of these cases to stop the fire. So which essential components does water remove? Yes, students, here we see that water removes, okay, heat. Okay, water removes heat in order to control the fire. So when heat is removed, the fire will stop burning. So here, water cools the combustible material so that its temperature is brought below its ignition temperature. Okay, water cools the combustible material so that its temperature, this substance, when we pour water on the substance which is burning, it will cool the combustible material or the combustible substance. Now if it does not reach its ignition temperature, it will not burn, right? So by use of water, we remove heat, we lower the ignition temperature, and that is how we control fire, by the use of water. Okay. Alright, students, let us see another example. Here we see two boys watching television. When suddenly there is fire in this socket. Yes. Then both of the boys, they recall this fire triangle. Okay, they recall this fire triangle. Now they are thinking which essential components to remove in order to stop this fire. Okay. So they both recall. One of the boy thought of removing oxygen. The other boy thought of removing heat. So they both went their separate ways and came back to the same room to put off this fire. One of the boy brought sand, the other boy brought water. Then this boy told the other boy, Mintu, that is, no, Mintu, don't throw water, wait, okay? And let us see, okay, what this boy does with the sand. Okay, so here the boy threw the sand into this socket and the fire stops burning. Then Mintu told his friend, I could have also put off the fire with water. I would have brought down the temperature below ignition temperature. Yes, students, do you agree with this, Mintu? Let us see, okay? So the other boy replied, no, Mintu, we could have got electric shock. Instead, I cut off the oxygen supply by throwing sand. Okay, so here we see that we cannot always use water to put off the fire. Yes, students, it is because water is the good conductor of electricity. So if you pour water, you will get electric shock. So we cannot use water to put off electric fires. So do not use water to put off electric fires. But in case of electric fires, we can control the fire, or we can put off the fire either by throwing sand to cut off oxygen supply, or we can use carbon dioxide fire extinguisher to cut off oxygen supply. All right, let us see another example. Here we see that a person is on fire and is running around. Then the other person, the people around him, came with a blanket and wrapped the person on fire around the blanket to control the fire. Yes, students? So here, what was the purpose of the blanket? Which essential components did they remove when they used the blanket to wrap around the person? Yes, students? So when they used the blanket to wrap around the person, they cut off oxygen supply. Yes, students? So blanket cuts off the oxygen supply. So when a person is on fire, the person must not run around because there is oxygen. When the person runs, there will be more supply of oxygen. So it will burn more intensely. But what can be done is wrap the person with a blanket, with a thick blanket, to cut off oxygen supply in order to control the fire. Another case we see here, we see a woman, a lady and a boy cooking in the kitchen when suddenly this pot catches fire. Now the boy asks his mother, hurry up mom, do something, do something to put off the fire. Then the mother, out of shock and surprise, she did not know what to do, so she expressed herself saying, oh fire, what to do? Then this boy, he recalled this fire triangle that he had learned in the class. Then he hand over this lid to his mother, and then they covered this pot on fire with lid, and the fire stopped burning. Yes, students, so here we see that the cut off oxygen supply by covering it with a lid. So they were able to control the fire and put off the fire. Water is not suitable to those fires involving petrol or oil. Why? So when this frying pan is on fire, it is not suitable to pour water there. Why? We will find out, but before that, let us answer some few questions. Please get your rough devices ready. The question is, if a person clothes catches fire, the best way to extinguish fire is to, we have 4 options. I'm giving you 30 seconds to respond to this question. Your time starts now. If a person clothes catches fire, the best way to extinguish fire is to, which of the following? Option A is cover the person with a blanket. Option B is cover the person with a polythene sheet. Option C is throw water on clothes. Option C is use the fire extinguisher. Yes, students? Alright, students. So, yes, very good. The correct answer for this question is option A, that is cover the person with a blanket, to cut off oxygen supply in order to put off the fire. Alright students, let us answer one more question. Please get your rough devices ready. The question is, the most common fire extinguisher is which of the following? Okay, water, carbon dioxide, sand, oxygen. We have four options, A, B, C and D. So which of these option is the correct answer? I'm giving you 15 seconds to respond to this question. Your time starts now. The most common fire extinguisher is water or carbon dioxide or sand or oxygen. Yes students. Alright students, your time is up, and yes, very good. The correct answer for this question is option A, that is water. Okay, water is the most common fire extinguisher because it is easily available to everyone. Yes students, so the correct answer is option A, that is water. Alright students, so coming back to our question, okay, let us see here. Let us do an activity. So take a big beaker, empty beaker, okay. Take another beaker, fill it with oil, and another beaker containing water. Now let us see what happens when we mix water and oil. Okay, so first pour water into the bigger beaker, then pour the oil into the beaker. So what do we observe here? We see that when we mix, okay, when we try to mix water and oil, they do not mix, but we see separate layers of oil and water. Oil layer is on the top, water layer is at the bottom. Yes students, so they do not mix. Yes, so here coming back to our questions, water is not suitable to those fires, okay, to put out fire or to extinguish fires involving petrol or oil. Why? Now we have just seen, right? Water is denser than oil. Okay, water is heavier than oil. So therefore it sinks below oil and oil will continue to burn on top of it. So suppose you have a pot, okay, which contain oil and is on fire. Now when you pour water on this, the water will settle down at the bottom and this oil will continue to burn. Okay, and that is why water is not suitable to those fires involving petrol or oil. We can either use, okay, we can cut off oxygen supply to stop the fire involving petrol or oil. So we have seen that the boy gave the lid to his mother to cover the pot, to cover the utensil. So they cut off oxygen supply and the fire stops burning. Or we can use, okay, carbon dioxide fire extinguisher to cut off oxygen supply in order to control fires involving petrol or oil. Okay. Alright students, we have another question. Please get your rough devices ready. The question is, fire produced by oil cannot be controlled by which of the following? Okay. Option A is carbon dioxide fire extinguisher. Option B is water. Option C is both of this. Option D is none of this. So I'm giving you 15 seconds to respond to this question. Your time starts now. Fire produced by oil cannot be controlled by which of the following? A, B, C or D? Carbon dioxide fire extinguisher, water, both carbon dioxide fire extinguisher and water, none of this. Alright students, your time is up, and yes, very good. The correct answer is option B, that is water. Okay, fire produced by oil cannot be controlled by water. We have just seen the explanation of it. Water is denser than oil, so it will sink below the oil and the oil will continue to burn at the top, on the top. Okay, so water cannot be used to control fire produced by oil. Okay, so option B is the correct answer. Alright students, so let us see. So fire is our best friend when it is under control. Yes, it helps us. We use fire for different purposes. We need fire to survive. Yes, so fire is our best friend when it is under control. But when it is uncontrolled, it is very dangerous. So we should never leave fire unattended or uncontrolled. Alright. Alright students, so controlling fire. How to control fire? We have seen that we can control fire either by removing the burning fuel, by cutting off oxygen supply, and by cooling the burning material. Okay, so here we see fuel, oxygen, okay, and cooling. So this is heat. Okay, so we can control fire either by removing fuel or oxygen or heat. Okay, so we can control fire by removing the essential components for combustion. Alright students, so in today's class we have discussed about the types of combustion. The first type of combustion we discuss is rapid combustion. Can you recall what is rapid combustion? So rapid combustion is instant combustion with release of large amount of energy in the form of heat and light. One example we discussed is burning of gas, right? Burning of LPG. So burning of LPG is an example of rapid combustion. The next type of combustion we discuss is spontaneous combustion. So what is spontaneous combustion? Combustion which takes place spontaneously without any external supply of heat is known as spontaneous combustion. Example we have seen is that when we take out kerosene, when we take out sodium pieces from kerosene and put it in open space or open air, it catches fire on its own. So that is an example of spontaneous combustion. The next type of combustion we discuss is explosion. So what is explosion? Explosion is a quick combustion with sudden release of enormous amount of energy in the form of heat, light, and sound. Okay. The next type of combustion we discuss is slow combustion. So slow combustion is the reaction which takes place slowly with release of small amount of energy. With release of small amount of energy in the form of heat. Okay, so we have discussed four types of combustion: rapid combustion, spontaneous combustion, explosion, and slow combustion. Remember students, in spontaneous combustion there is no supply of external heat, and in explosion loud sound are produced. It is due to rapid expansion of gases. Okay, so these are the different types of combustion. Now we have discussed how to control fire. Yes, so how do we control fire? We have already learned the essential components of fire, or essential components for combustion to take place. So we can control fire either by removing any one of the essential components, that may be fuel, oxygen, or heat. Okay, we have seen that we can use water, okay, to control fire. Why? Because water cools the combustible material. It cools down the combustible material. So water helps in removing the heat. Okay, water helps in removing the heat. It brings the combustible material under its ignition temperature, so that we use water to control fire. Now we cannot use water in some situations. We cannot always use water to put off fire. For example, in case of electric fires, we cannot use water because water is a conductor of electricity. So we will get shocked if we try to put off electric fires with water. So what do we do here? In case of electric fires, we cut off oxygen supply. So how can we cut off oxygen supply? We can cut off oxygen supply by throwing sand at the sockets, right? We can also cut off oxygen supply by using carbon dioxide fire extinguisher. The next we have seen is when a person is on fire. Okay, when the person is on fire, we can control the fire by wrapping the person around the blanket. And here the purpose of blanket is to cut off oxygen supply. We have also seen in case of fire involving petrol and oil, we cannot extinguish the fire by using water. Suppose your frying pan is on fire. If you pour water into your frying pan, the water will sink below and the oil will continue to burn. So we cannot control fire involving petrol or oil by making use of water. So what should we do here? Here also we can control fires by cutting off oxygen supply. You can cover your frying pan with a lid. so that there is no supply of oxygen. Okay, or you can use fire extinguisher, to carbon dioxide fire extinguisher, to cut off oxygen supply in case of petrol fire or oil fire. So we have discussed some of the along with some of the examples, we have discussed how to control fire. Yes, students, and at the end we can summarize controlling fire into these 3 points. That is, we can control fire by removing the burning fuel, we can control fire by cutting off oxygen supply, and we can control fire by cooling the burning material or by removing the heat, and by decreasing, okay, or by lowering, by removing, okay, by cooling the burning material such that we bring the ignition temperature down, okay, such that we bring the temperature of the burning material below its ignition temperature. So these are the 3 ways, okay, we can use, or these are the 3 ways to control fire. Okay, I'm repeating this. We can control fires by removing the burning fuel, we can control fire by cutting off oxygen supply, and we can control fire by cooling the burning material so that we brings the temperature of the burning material below its ignition temperature. Alright students, so I hope you are clear with what we have discussed today. This leads us to the last question for today. Please get your rough devices ready and give your feedback about today's class. So how do you feel about today's class? I'm giving you 25 seconds for this question. Your time starts now. Yes students, so how do you feel about today's class? Happy, quite good, satisfactory, or confused? Yes students, please give your feedback about today's class. Alright students, your time is up. Okay, thank you for your response and thank you for joining today's class. I will see you again in our next class. Till then, take care everyone and have a nice day.